Hello and welcome to Tech Deals. For the past 10 years, we have been treated to one of the last great leaps forward in PC technology, the move from hard drives to solid-state drives. Few improvements in recent PC memory have been as dramatic as the first time you booted up your computer from a new solid-state drive. To be fair, such moments have existed before. After all, the first time you installed a 3DFX Voodoo card and experienced real hardware 3D acceleration on your computer for the first time, the first time you installed an AdLib or a Sound Blaster sound card, for those of you who go back that far, and the first time we moved from floppy disks to CD-ROMs, being able to pack 500 times the data into something that basically costs the same amount of money, one CD being about the same as one floppy. But those evolutions and revolutions are all many decades in the past, going back to the 90s and even the late 80s. Today, in 2019, SSDs are kind of the final frontier. Today, we have another great leap forward in technology, 3D Crosspoint from Intel, otherwise known as Optane. It is solid-state storage, but it is not the NAND, N-A-N-D, it's an acronym, that all of your current SSDs are based on. It is an entirely new technology. It is 10 times faster in terms of latency and random access time or more compared to the existing SSDs, even the super premium ones, and it comes with some other benefits as well, which we will talk about. It is currently quite expensive, and I am not encouraging anyone to rush out and buy this today. This is sort of a forward-looking video to give you a preview of what you may very well find to be common in the next few years' time. After all, when SSDs first came out, they were very expensive and not common at all. And of course, they've improved tremendously since that time, largely displacing hard drives as the boot devices and even now game drives for many PC enthusiasts. This may very well be the same way over the next 5 to 10 years. Today, we're going to take a look at 3D Optane. We're going to look at its performance compared to NAND drives. We're going to talk about the technology itself and some possible interesting features beyond just storage drives, because Optane has the ability to do more than just provide storage. So let's get into it. So what is 3D Crosspoint, you ask? Well, it's kind of a bridge between NAND in your SSDs and DRAM, which is your DDR4 system memory. It is truly random access. It does not have the read, modify, write cycle requirements of NAND. It doesn't require all of the buffers and some of the other tricks necessary to make NAND feel fast. Modern SSDs run much faster than the original SSDs. They've learned how to kind of mask the inherent limitations of NAND technology, which 3D Optane does not suffer from. It does, however, suffer from price. It's currently quite expensive. We'll talk about the price in a minute, but technology prices tend to come down with time. Remove the price barrier and it becomes quite interesting. Another thing worth noting is 3D Crosspoint does not have the endurance limitations, within reason, of NAND. It has far more endurance, and we'll talk about that as well. While we're on the subject, let's talk about endurance. The excellent Samsung 970 EVO Plus 1TB NVMe SSD, currently considered to be one of the best general devices on the market, has a 5-year warranty or 600 terabytes total written, whichever comes first. So either 5 years and the warranty expires, or 600 terabytes written and then the warranty expires because the drive keeps track of how much is written. Now, in fairness, most consumers on their general desktop PCs do not need to worry about that. 600 terabytes is more than most of you will write in 5 years to one of these drives. So from a pure storage point of view, for the average consumer, this is not currently a big deal, but it does restrict it to just basically being bulk storage. How about Optane? Well, this is a 1TB drive, and this is a 1TB drive. Well, 960 gigabytes. It's really, really close at just 4% smaller than this drive. Does it have 600 terabytes total written? Yes, and a whole lot more. This is the consumer version of the drive, and it has 17.5 petabytes worth of warranty. That is 29 times the write endurance of the Samsung 970 EVO Plus. More than most of you will ever need, but I mentioned DRAM. We'll come back around to that. That is worth remembering because that is a level that is so far beyond what the average person needs, it opens up some interesting possibilities with 3D Crosspoint that simply don't exist with NAND. And that is the current consumer version drive. NAND drives didn't used to be this good either. The data center version of this drive has 4 times more warranty write endurance than this does. The reality is this drive will last virtually forever. It's just they lower the warranty to keep data centers from buying the consumer level drive, which is less money. I've mentioned price several times in this video. Let's come back around to price. The Samsung 970 EVO Plus 1TB drive is currently $230. The almost 1TB Intel 905p Optane drive is almost $1,200. Now, go ahead, pick yourself up back out of your chair. You don't have to fall on the floor. Yes, it's $1,200. I know. Many of you, your entire computer isn't $1,200. I know, I get it, it's expensive. I would like to point out that in 2010, I bought a good old-fashioned normal NAND SSD off of Newegg, 160 gigabytes, 0.16 terabyte, for $550, the original Intel X25 G2 drive. So that was 320, or roughly a third of a terabyte, for $1,000. And that drive today is slow as molasses compared to these NAND-based drives. Even the QLC 660p just blows it away. I mean, it's easily 10 times as fast, if not faster, in both sequential and random. So that was 9 years ago. What is this drive going to be in the next 5 or 10 years? Who knows? But yes, it is currently $1,200, which is really expensive for 1 terabyte of storage. However, it has 29 times the write endurance for warranty purposes, and probably far more, than the Samsung drive, which, in fairness, will run beyond 600 terabytes as well. It is more expensive, but it is not 29 times more expensive. And if you have some application that needs to write a lot, if for some reason you are the 1% of users who legitimately need massive write endurance, you're running a database, you're using a multi-user workstation, you have a server, you have something running in the background that's constantly doing writes to the drive, whatever your application, if you have something that legitimately just writes all day long to a drive, this is actually the deal. Because you'll replace this Samsung drive several times over for the same money, and this will keep right on trucking. Granted, you'll have more total storage if you buy them all at once, but legitimately for people who need that kind of endurance, this really is a deal. It's just most of you don't need that endurance, but it is pretty cool. For those of you who legitimately do have data centers to fill, the D4800X version of this, 1.5 terabyte, so it is 50% larger in fairness, has an 82 petabyte write endurance over 5 years. That is 30 full drive writes per day, 365 days a year for 5 years. Which is a lot, even for probably some data centers. But if you need write endurance, if you need a drive that you can pound on and do 30 full drive writes, they have it. Now, it's not $1,200. The D4800X is $4,500. But if you take the price of that and divide it into the write endurance and compared it to NAND-based SSDs, it actually is the value if you have such an application. Which, yes, I know, again, most of you don't, but these used to be expensive, and this video is more about a cool technology that I think over the next 5 to 10 years will matter, if maybe not so much for most of you today. That level of endurance brings up something interesting, and it is happening today in some servers, and software at the server level is being rewritten for this. Optane does not just come in storage devices such as this that are accessed via drive letter. They are also making Optane in DIMMs, like DDR4 DIMMs that you would put into a memory slot. Picture a very large server with perhaps 2 or 4 processor sockets with 4 terabytes of DDR4 RAM and 32 terabytes of Optane, providing 36 terabytes of addressable memory separate from storage directly through the DIMM modules in the memory controller of the CPU. Now that does require software that is Optane aware. It requires an operating system that is Optane aware so that it can do the majority of its reads and writes and accesses within the DDR4 modules. And it sort of creates a second stage memory storage between RAM and your actual storage, like your drives, your C, D, E, etc. Rather than trying to just make NAND faster, which does have its limitations, it lets you create something in between with a direct memory bus to your CPU. Large memory spaces are an issue on servers, which is one of the reasons why this technology was developed, to allow you to install Optane directly into the DIMM modules. You might have 2 or 4 of the modules filled with DDR and the rest filled with Optane, and if you have an operating system that's aware of it, you gain far more addressable memory, and then the OS can manage what goes where. This, again, does not apply to consumers today. Nowhere in the consumer world does that technology apply today. However, 5 or 10 years from now, how about this for an interesting thought? Because of the write endurance of this, what if you didn't need storage? What if a future computer 5 or 10 years from now could have a terabyte of RAM, of which 64 gigs was volatile memory, which is what you run most of your programs in, and the rest of it is non-volatile memory, but it's all installed in your DIMM slots, and your operating system manages it, some future version of Windows 10 or 11 or 12, and you basically just put your programs in and it handles where everything is. I don't know if that's ever going to be a thing, but it's interesting to think about in terms of memory management and storage management, because think about this for a minute. Do you worry about where your files are kept or how things open or close when you, say, grab your iPhone or your Samsung Galaxy Note or some other sort of mobile device? They kind of have storage and they kind of have memory and the system just handles it. Well, maybe our PCs will be like that someday. SSDs currently can't do that because there's not enough write endurance on NAND to make that happen, possibly with Optane. I realize all that might sound a little bit crazy and out there, but consider that 25 years ago when we were making the move from floppy disks to CD-ROMs, 16 gigs of RAM, you'd have been taken off to the crazy bin. 16 megs of RAM was a good amount of RAM back in the mid-90s. 16 gigs of RAM was a fantasy. And today, everybody can have 16 gigs of RAM. $59 on Newegg today will buy you 16 gigs of DDR4 3000. That's remarkable. 64 gigs of RAM is under $300. When did that happen? It is not that expensive to get truly large amounts of RAM for consumer machines or even high-end desktops. Speaking of high-end desktops, this is a really good time to mention that all the benchmarks you're about to see in the video today were done on the Ryzen 9 3900X and this wonderful MSI X570 motherboard. However, nobody in their right mind is installing a $1,200 SSD in that platform, nice as it is. I tested it there because that's where I tested everything else, and to keep it the same, that's the only thing that really is fair and makes sense. But the reality is, if you're going to get a drive like this, you're going to install it on a CPU like this. This is an i9-9980XE 18-core 36-thread $2,000 Intel CPU. I didn't mention it earlier in the video, by the way. Thank you to Intel for sending me this and this, because otherwise I couldn't afford them. But they did, and I will be upgrading my 8-core 16-thread Skylake X build, which was the 2017 $4,000 Ultimate System build. That video is on my channel if you're interested in taking a look at it. That system is getting a new refreshed X299 motherboard. It is getting that CPU. It's getting this as a boot drive, 128 gigs of RAM, and it's replacing my 16-core 32-thread Threadripper for my primary content creation, and that will be a completely separate piece of content. This just seemed like a really good point to insert that detail. Rewinding back to today in 2019, what about the Intel 905p 960GB Optane SSD for $1,200? It does offer some features that no NAND-based SSD provides beyond endurance. We already talked about endurance. What about performance? It must be really fast, right? Yes and no. Performance is complicated, and so that's going to require a bit more of a deep dive. What do I mean? Quite simply, the sequential transfer rate of Optane is lower than it is for premium NAND-based SSDs. The Samsung 970 EVO Plus, the new PCI Express 4.0 drives, these are faster in read and write in sequential performance than Optane is. And some people are going to look at those big pretty numbers and go, wait a minute, what happened here? This is such an expensive drive, it's so slow, it's terrible. But as I mentioned when I recently reviewed the PCI Express 4 NVMe drives, sequential performance means virtually nothing. It's nice, but unless you're copying files all day, which, okay, 0.1% of you are, that number means almost nothing. It means almost nothing for single-user desktops. It means almost nothing for multi-user desktops, for servers, for workstations. It's random performance that means everything, and random performance is where it's at. I mentioned way back at the beginning of this video that Optane does not have to go through the read, modify, write cycle to refresh an entire page of NAND cells the way NAND-based SSDs do. Now, they mask it with buffers and cache and a few other things. And in burst performance, NAND-based SSDs can be really good, but they fall apart in sustained transfer rate. Even the premium drives. I don't have one up here at the moment, but a Samsung 970 Pro is a true MLC 2-bit per cell, no SLC cache, true honest-to-goodness, high-performance professional drive with a 1.2 petabyte write endurance. Twice this. It is also a lot more expensive. It's not $200, it's way more than the Evo drive is. However, it has true honest-to-goodness MLC. Samsung, by the way, advertises the Evo Plus as MLC. Yeah, Samsung's cheating there. They call everything with 2 or more bits per cell as MLC. This is a TLC drive. Don't let them kid you. It has an SLC cache, it has DRAM buffers, and its performance falls apart far more than the Pro drive does because of that. So just something to keep in mind. But there's also more to performance than just straight sequential full drive writes and how many accesses and how long you spend hitting the drive with continuous either reads or writes, either sequential or random. I've got some charts here we'll take a look at here in a second. But if you legitimately have a seriously heavy workload, Optane is going to absolutely destroy NAND-based SSDs in terms of performance. And if you watch my recent RAID SSD video, you'll know that does absolutely nothing for NVMe performance. If you legitimately need long, continuous reads and writes, multi-queue depth, mixed workloads on a single drive, Optane may very well actually be worth the money in terms of overall performance, assuming that you cannot split individual workloads across multiple drives. If you could buy, say, 4 different NVMe SSDs and split the workloads across them, that might mediate that to some extent versus putting everything on one drive. But that's not always possible. Single applications might just simply hammer the drive. So that might be one place where Optane wins. Again, I feel the need to emphasize I am not making this video to encourage any of you to go out and buy one of these drives. I'm grateful for Intel sending it to me, and it'll be nice to have in my super premium high-end content creation machine, but it is not for most people. I'm not entirely sure even I really need it as much as I'm going to have fun with it. The truth of the matter is most people should buy the Intel 660p. I have those in my content creation machine, and I will continue to use them for scratch drives for storing raw media files, and I have them as game drives on multiple machines. It's the game drive on my Ryzen test bench, for example. All the games I use for benchmarking are now installed on a 2 terabyte 660p. $185 for 2 terabytes is an incredible value for the money. So if you look at my channel name of Tech Deals and you want to know why a $1,200 SSD is on it, keep in mind, this is more supposed to be a video that you enjoy watching and then you go buy one of those. I debated long and hard. Actually, I took several days between my initial testing of this and the filming of this video trying to decide, do I want to do extensive, deep runs on these SSDs to demonstrate what Optane can really do? I ultimately decided not to for 2 reasons. Number one, it's about 3 days worth of full work. It is a lot of work to do full drive writes repeatedly in multiple modes, repeat the test several times for accuracy, and then repeat it times several drives in order to get some results. And frankly, this drive didn't come out last week, and several other reviewers have already done it. And in this case, I'm going to refer you to TweakTown, who I am borrowing 3 of their charts, but they have a lot more, at least a dozen charts, and I will link to their review down in the description below because frankly, they did a they must have spent a week testing this drive extensively, running it and continuously from start to finish with all of their benchmarks. I do encourage you to check out their review down below, but of course, that is a website review, and some of you might like watching videos or to see my take on it. So I'm gonna scoot over this way, and I'm gonna show you 3 charts. The first chart I want to show you is sequential steady state, which is something you'd think all the drives could do just fine without an issue. You'd think so, but when you start doing full drive reads and writes, you might find that's not the case. On the ends, on the peaks, you'll see the Samsung 970 Pro, the true MLC drive, which is quite expensive, did exceed the Optane drive just a bit. And a couple of the drives on one end also exceeded it. But take a look at that nice smooth line straight through the chart. That's Optane. That is consistent performance if there ever was one. And that is, it doesn't need tricks or masks or buffers or anything else in order to give you smooth, steady performance. It just does it because it is not NAND, it is new technology. All the other SSDs were frankly up, down, and all over the place. It is also worth noting that every single NAND-based SSD, including the 970 Pro, dropped below 1 gigabyte per second at least once, and many of them spent quite a bit of time under there. Optane never dropped below 2 gigabytes per second. So while its peak pretty benchmark numbers are not as high as, say, the Samsung's, its sustained full performance actually is. The second chart is 4K random steady state. And this shows the difference between NAND and 3D Crosspoint even more starkly than the first. The Intel 905p just doesn't care. It's Crosspoint, it's not NAND. It just carries right on through like nobody's business. Random, sequential, it's all kind of sort of the same thing to this drive. It held about 137,000 IOPS all the way through the test. It just doesn't care. Every other NAND-based SSD dropped below 40,000 IOPS, even the 970 Pro, and many of them dropped way below that. There is a huge disparity in real-world heavy performance when you're actually doing large data sets as opposed to just like a 1 or a 4 gigabyte test between Optane and these NAND-based drives. The third chart is PCMarks Extended Storage Test. This is a real-world test using drive traces of real applications, the extended, more challenging version than the standard one, and this also shows the dramatic difference between intensive use between Optane and NAND in the real world. The 905p was 4 times faster than the Samsung 970 Pro, and up to 10 times faster than some of the other drives tested. Even some of the drives that look nice in the pretty crystal DiskMark benchmarks don't actually do as well on this test. It just takes a long time to run, and it's another example of a test that I would do if I had infinite amount of time, but we're using theirs, and it just demonstrates how Optane sort of looks at all of these challenges and goes, is that the best you could do? Whereas the NAND drives go, mercy. So it's very, very cool. It's just expensive. When the price comes down, I would not be surprised in 5 years' time if our boot drives become 3D Crosspoint and our game drive or storage drives become NAND-based SSDs. What we may see is a transition where small Optane drives become the boot drives for performance premium builds, and then we do bulk NAND storage. That might also be a transition point. This is really impressive and really cool. I wish I could convey to you through a video, just more than just a chart and more than just talking, at how this, it's a different level of experience. It's not, let me be clear about something. It is not the mind-blowing experience of moving from hard drives to SSDs in the first place. It's not quite that big of a leap, but it is a big one if you are an intensive user and if you do a lot with your computer. If you have a lot going on, multiple background tasks, a drive scan, a backup, a compression, a video encode, if you've got a lot of stuff going on like I often do on my machines, well, that's why this is going into my new build. Having shown you those tests, yes, I did run my standard Crystal DiskMark test, which really is the wrong benchmark for this drive, which is why I showed you Tweak Towns. Again, check out their link in the description below. But here are my benchmark results. First up, we have the Sequential Q depth of 32, thread count of 1, same as I've been running for a while. You can see here the results of the recent reviews that I've done on the PCI Express 4 drive. That's the red bar, the Gigabyte Aorus 1 terabyte, and then the orange and yellow in RAID 0. The Samsung 970 EVO Plus, which is the green bar, the Intel 660p, and then we've added the purple bar, the Intel 905p. Now, the Optane drive does beat the 660p, but I certainly hope it would. That's a budget drive. Notice that the other SSDs are all faster in sequential transfer rate. And this is the sort of chart, again, that people look at and go, well, it can't be that great then, can it? Well, again, this chart doesn't matter. Moving on to 4K random, Q depth of 32, thread count of 1, I would like to remind you that this is 4 passes of 4 gigabytes of data. This is not a lot of data, and it really isn't enough for these drives to really show the Intel. That should be a much larger chunk of data because you're not buying the 905p to do 4 gigabytes of data. 4 gigabytes of data fits into RAM cache. That really is a bit silly. So in that respect, that probably should be higher, and if I could go back in time and change it, I might do that, but, well, it's water under the bridge at this point. So for the purposes of this test, yeah, not much exciting going on here. Next up, we have 4K random, Q depth of 8, thread count of 8, and you can see much larger numbers here, just like in the sequentials, and the Optane keeps up with the other drives, but again, this is only a 4 gigabyte data test, so really doesn't show off what this drive can do. Finally, we come to Q depth of 1, thread count of 1, and holy smokes, look at the random read speed, 255 megabytes per second versus 60 to 78 on the other drives. Interestingly enough, the write speed isn't any faster, but part of that has to do with the fact of the caching algorithms. There's enough SLC cache, enough DRAM buffers on the various SSDs there. The Gigabyte, as an example, has a 1 gigabyte DRAM cache and a very fast set of NAND, so it doesn't really make any difference. And that's part of it. If these were larger writes, something perhaps like 100 gigabytes, 150 gigabytes, or if it was a mixed workload, then you would see a larger separation there. But again, it's just a 4 gigabyte data set, which is why it's there. But at least you can see one test with a huge and dramatic 4 to 5 times performance difference there on read speed. The future is here and it is awesome. It's just expensive. I know I've used the word expensive like 16 times in this video, but I'm being honest with you guys. As much as I appreciate being able to use this technology, I get that it's not for everybody. Time may change that. Technology was expensive, then it's not expensive. Will this be what we all are using in 5 years as our boot drive? Only time will tell. But the limitations of NAND are baked into that technology. NAND's never not going to have that limitation. It's inherent in how that works. It was true 15 years ago, it was true 5 years ago, it's true today. This doesn't have those limitations. It's a completely new solid-state storage technology that is non-volatile, doesn't lose it, and is only about 10 times slower in terms of latency access to DRAM. It's actually, in terms of pure latency access for the first byte access for the CPU, it's only about 10 times slower than DRAM, whereas NAND-based SSDs are between 100 to 1,000 times slower depending upon port implementation, etc., where the lanes are and whatnot. So it's a dramatically faster, closer, more responsive technology that may very well be needed as our CPUs continue to evolve and become faster. Whether or not we need a terabyte of it is another conversation. It might be interesting to have a hybrid drive at some point with like 256 gigs of Octane and maybe 2 or 3 terabytes of NAND and maybe use the Optane as a buffer. I don't know if that would actually help or be a benefit, but it'll be interesting to see what comes. Like this video if you like it, share it with your friends if you love it. Remember to subscribe to my channel with the big huge red button directly below. Questions, comments, thoughts, feedback, suggestions. What did you think of this video? That's what that comment section is down there for. I don't respond to every comment because I get a lot of them sometimes, but I promise you I do read them all. Links in the video description below. For the 2 of you who might ever consider buying one of these, I will put links to this down below. There are smaller versions of this drive. You don't have to get a 1 terabyte version. They do have less expensive, smaller versions. If you're building a $3,000 or $4,000 super premium, no holds barred, everything build, and you want a 480 gig version, maybe you splurge and buy yourself something awesome and use that as your boot drive. I will link to my recent NAND-based SSD reviews down there, and of course I will link to these on Amazon and Newegg as usual. And I will even link to the Intel i9-9980XE $2,000 18-core CPU, even though probably none of you are going to buy that. But it is very cool. And I will be doing a video on the rebuild of that machine soon. I didn't actually film the actual overhead of tearing it apart, replacing the motherboard, and changing out the components. I thought about it, but I thought you guys would be more interested in some benchmarks and comparisons and to see how it compares to my current workstation, which is the 16-core Threadripper. Yes, that's faster. But for how much money? We'll talk about that in that video. Thank you all so much for watching. I will see all of you next time.